When it comes to figuring out all you can about an extinct mammoth and its world from its remains, there's nothing quite like a good piece of poop. Now, it may not look like much to you or me, but to a paleoecologist, this poop is a priceless gem. Such a specialist can hardly wait to get his hands on this poop. And what they're looking to do is to ferret out all its long-held secrets. In this feature, have a look at the primeval goodies that scientists have teased from the dung that you're looking at now, and what those leftovers have revealed about the mammoth, as well as its diet, habitat, even the climate in which it lived 22,000 years ago. And here you're looking at the specimen. The dung was packed within the intestine of this frozen woolly mammoth. It's known as Yukagir mammoth for the Siberian village near where it was found in 2002. The mammoth's permafrost tomb preserved its head, tusks, front legs, and parts of its stomach and intestinal tract. From its bones and enormous tusks, the scientists who rushed to the site, including mammoth expert Dick Mole on the left and Larry Augenbrod on the right, they guessed that the mammoth was an old male that, when alive, stood over 9 feet tall at the shoulder and weighed 4 to 5 tons. From the dung ball, well, they learned heaps more. Take a look at this. Grass. The main components of Yukagir's final meal was grass, including these stems from the Poaceae family. Remarkably, like many of the dung's floral remains, the stems have remained their color and shape ever since the mammoth tore them from the tundra 22,500 years ago. Now, radiocarbon dating has supplied the estimated age we just spoke of. Now, earlier studies had shown that grasses and sedges and rushes comprised the bulk of the diet of the Siberian woolly mammoth during the Pleistocene. So this discovery came as no surprise, but it was only the most obvious of the findings. And then they found seeds. The stool held grass seeds as well, including this seed from a species identified as Poacf artica. The CF means conifer and indicates that the primordial species resembles a still living species, but is not confirmed to be the same. To identify such macrofossils or visible parts, the international team that analyzed the dung boiled bits of the poop, sieved the remains, floated them in a petri dish full of water, and then studied them under stereo microscope. Such seeds and other floral bits enabled them to flesh out the mammoth's ice age environment. And on top of seeds, they found moss. For microfossils and other largely invisible stuff, the team relied on methods with mouthful names like thermally assisted hydrolysis and polymerase chain reaction amplification. One such tiny ingredient in the poop was mineral dust, seen here in gray, coating a piece of moss. Wind would have lifted up this dust from eroded patches of the ground, covered plants with it, and when the mammoth ate the plants, he took in these minerals. The presence in the giant's gut of mosses, such as this one, showed that his surroundings were not all dry grassland. In fact, there were moist areas that existed there as well. And on top of the moss, they found twigs. Another sizable portion of the mammoth's last supper was willow. And this is where it gets extremely interesting. These were not the big bushy willow trees common in temperate areas today. Rather, The stems at left that you're looking at here came from small-leaved dwarf species known as Salix arctica. The twigs had been broken but not digested, leaving the scientists wondering whether the mammoth could possibly have absorbed sufficient nutrients from his food. The lack of attached leaf stalks on the twigs also led them to infer that he had died between 2 growing seasons. And then there were the leaves in the stomach. Clearly, they had not been completely digested. And the dung offered up willow leaves. All were badly preserved, and none of them was connected to a twig. Further evidence that the mammoth had perished between growing seasons. The team thinks, in fact, that the Yukagir mammoth may have eaten and partially digested dead leaves. Was this because little else was available at the time of his death? Just how harsh was the climate at this time, 22,500 years ago? In what season of the year did he die? Well, the scientists were able to look at the tree rings on the willow. To help find out, the team sliced thin cross-sections of the willow twigs. The thickest twig was less than 1/5 of an inch in diameter, yet it bore more than 20 annual rings that were 20,500 years ago. This is mind-blowing. Now, the growth rate is even slower than that of modern Salix arctica, indicating that the mammoth's climate was even more austere than that of northern Greenland, where S. arctica lives today. The cross-sections were even clearer as the season of death. As you can see here, the dark bands here and here and here was where the death occurred. When the mammoth ate the willow, the first spring vessels of the outermost rings were just forming, a clear sign that this mammoth had died in the early spring. And then there was the pollen. Pollen abounded in the dung. The majority of the grains of pollen were of wind-dispersed pollen, such as Artemisia, a type of sage, which is the top pair. The dung also retained small amounts of insect-carried pollen from a variety of flowering plants, including Polemonium, commonly known as Jacob's ladder, which is the bottom pair. The pollen record was likely influenced by the mammoth's food choices during his final meal. The pollen probably integrates several years of plant growth, but one finding was unequivocal: the total absence of tree pollen. In the mammoth's world, it was treeless. And this is the spot where the mammoth was found. Not too hospitable, now was it? Since the area remains treeless today, his home may have looked largely the same. Paleo experts, like myself, have given the mammoth's ancient habitat a name: the Mammoth Steppe. It was a cold, arid plain, but with moister meadows here and there, and water was likely available year-round, including snow in winter and streams or standing water in summer. Several plant species identified in the dung, including marsh marigold, require permanent water, and the mammoth certainly drank from freshwater pools, as indicated by the green pond algae found in its stool. The absence of any trees in his ecosystem marks a significant change in the usual diet of Siberian woolly mammoths, also known scientifically as Mammuthus primigenius. In all other Siberian mammoth dung analysis to date, scientists have recovered twigs of alder, birch, larch, and spruce. Mammoths nibbled these trees to get nutrients lacking in the grasses. Since no trees of any kind lived in his neighborhood of this mammoth, the Yukagir mammoth may have consumed the dwarf willow shrubs, including this bud, with nascent leaves visible within, to get vitamins lacking in the meadow grasses. Still, other nutrients came from the dung. Dung the mammoth ate. Animal droppings may have supplemented his daily intake of grasses and other vegetation. Here, a moss spore structure. The team recovered fruit bodies of a dung-inhabiting fungus that only develops at least a week after manure is exposed to air, which the mammoth's own poop never was. Therefore, the swallowed stool was probably mammoth dung. In fact, among living mammals, elephants, with hyraxes and manatees, are unique in having no bile acids, and none were found in the feces of the mammoth, a close relative to the elephant. In the end, the team was unable to determine the cause of death for this particular mammoth. Here, one of his front legs shown in situ, which means nothing more than in place. His molars were heavily worn, another possible indication that he was malnourished and eating feverishly to try to gain nutrition. Another possible indication, well, that something else was happening to cause his death. The added stress of a severe winter may have sealed his fate. As Dutch scientist Bas van Giel and his 15 co-authors write in the 2008 paper, which will be linked below, on which all of this story is based. The start of the growing season might have come too late for this animal. Lying down in a sheltered hollow, he died, malnourished, and became covered with a thick mud layer that froze and preserved part of him for over 22,000 years. And that's a boom to knowledge. Hope you got something out of the video. Completely fascinating. The mammoths and all the information you can get from just some of the poop that has been frozen, time immemorial, for 22,500 years. Eons of information perfectly preserved. These twigs look like they were buried yesterday. And yet we know otherwise. Be safe. We love you. Subscribe to the channel if you haven't. Become a Patreon. Support the work we do. We love you. And we'll see you soon with another boom.